Okay, so this is just a thing on just differentiation of log functions, and we also need to look at integration of log functions as well, and also differentiation of exponentials and integration of exponential functions as well. Okay. Alright, so if you have y equals log base e of x, then basically y dash will equal 1 over x. Now the basic rule on that is log of e of f of x, then y dash will be f dash x on f of x. And that basically is on your formula sheet. If you have log base a of x, then y dash will be 1 over a over x. See, it's almost the same. See how it's the same as this? But you have to, remember you have to attach a lin a. Okay? And if we did the most basic one with the f of x, then y dash would be f dash x on f of x, but you have to attach the lin a. That would be the difference. Now I might just do a quick proof just with the a to the x, just to show you. Like if I look at that there, the first thing that you do is the first thing you could do here to work out how to do it is if you log both sides, so you get log y, and I'm going to make it a base e because we know the rule for differentiation of base e. The x comes down the front, so you get x log ea equals log ey. So that's x equals log ey over log ea. So when we go dx on dy, the y becomes 1 on y, and it's times 1 over log ea. Now, y is equal to a to the x, so it's a to the x log ea, which is basically the rule that I just did. Okay, so let's just look at differentiating just a few of those. So if you differentiate y equals ln of 3x squared minus 1. Okay, so just some quick differentiations on these. So differentiate the first one. Derivative of 3x squared is 6x over 3x squared minus 1, because it's f dash x on f of x. This one here, derivative of this, derivative of sine is cos. So it'll be cos x on sine x, and cos x on sine x is just cot x. The next one, derivative of cos x, is minus sine x. So it's minus sine x on cos x, which is minus tan x. Derivative of ln e to the x, y dash would be e to the x, so derivative of ex plus 1, that's your f dash x over ex plus 1. This one here is a uv, so u is x, u dash is 1, v is ln x, v dash is 1 on x. So when you multiply them, you get x times 1 on x plus 1 times ln x, which gives you 1 plus ln x. This one here, y dash, oops, it's a bit bigger dash, so y dash equals 4 ln x plus 1 to the 3 times the derivative of ln x plus 1, which is 1 on x. Okay, so that's differentiation a log. And we know differentiating an exponential, so y equals e to, say, the 5x, y equals e to the x squared, y equals e to the sine x. And then I just do some that maybe combine a couple of them and do a quote as well. Okay, so looking at this then, the first one, y dash equals 5e to the 5x. The second one, y dash, is 2x e to the x squared. The third one, y dash, sine goes to cos x e to the sine x. And the next one, y dash equals, okay, so we go u is ln x, v is e to the 2x, u dash is 1 on x, v dash is 2e to the 2x. So start off with the v, because it goes v u dash minus u v dash on v squared. So it's e to the 2x times 1 on x minus ln x times 2e to the 2x all over e to the 2x squared. So yeah, you could pretty much leave it like that. If you want to get rid of this yucky x here, you just times the top and the bottom by x, and it will cancel out of that one but come into that one there. So it'll end up with e to the 2x minus x ln x with a 2, e to the 2x all over x e to the 4x. Because when you square that, you multiply the indices and you get 4x. Now, I just want to do a tangent and normal one, just to refresh your memory. So find the equation of a tangent. So let's find the equation of the tangent. 2y equals 3e to the 4x at x equals 1. And then find the equation of the normal. So find the equation of the normal 2y equals ln x plus 1 at x equals 1. Okay, so differentiate to get the gradient of the tangent first. So you get 3e to the 4x times 4, which is 12e to the 4x. When x equals 1, that means y dash is 12e to the 4, because it's 4 times 1. We need to get the y value. So x equals 1, y is 3e to the 4 times 1, which is 4. So we have a point, which is 3e to the 4, and we have the gradient of the tangent, which is 12e to the 4. Just go y minus y1, 3e to the 4, equals 12e to the 4, x minus 1. Y minus 3e to the 4 equals 12e to the 4, x minus 12e to the 4. Okay, now 3e to the 4 and 12e to the 4, when you cancel those out, you'll end up with minus 9e to the 4. Okay, so y dash is 1 on x plus 1. When x equals 1, y dash equals 1 on 1 plus 1, which is a half. That is the gradient of the tangent. So y dash of the normal would be 2 with a negative, because you've got to flip and you've got to change the sign. Okay, so alright, so then we need a point. So go x equals 1, y is ln 1 plus 1, so y is ln 2. So there we go. Alright, y minus y1, so y minus ln 2 equals m, which is minus 2, x minus 1. Y minus ln 2 equals minus 2x plus 2. If I bring it all to the one side, put it into general form, you get plus 2x plus y minus ln 2 minus 2 equals 0.